We are asked to find the fourth power of the sine of 5x, but the tricky part is we need to write our answer in the given form here in a way such we could just fill in the blanks. So to start off, you would use the half angle identity that says that the sine of a over 2 can be written in the following way. So for starters, where you see a over 2 in this identity here, we have a 5x in our problem. So where I have a 5x in my problem, that lines up with a over 2 in the identity. So to figure out the value of a in my problem, you could solve this for a by simply multiplying both sides by 2. And the a that works for our problem would be to let a be 10x. So what do I mean by that is, if you were to let a be 10x, in fact I'm going to do that down here, if you, where you saw the letter x, was to replace it with 10x, what you'd have here is 10x divided by 2, which is 5x, which matches our problem. But if you put a 10x in for this a, you must do it for this a. So this identity becomes 1 minus cosine 10x over 2. So I think of identities as like a fill-in-the-blank thing. Whatever you put here, a, you need to put there. So our a is 10x. So here where you see an a, I put a 10x here. But if you back up a second, you remember that our problem wasn't just the sine of 5x. So right here, what we have on the left-hand side is the equivalent of sine of 5x. So there, write that. So again, 10x divided by 2 is 5x. But our problem was to the fourth power. So if you want this to the fourth power, that means you have to raise the right-hand side of this to the fourth power. And if you did that, just kind of simplifying down, I have that our problem is equivalent to this. But to simplify this, I'm going to make the argument that when you take a positive and raise it to the fourth power, you end up with a positive result. And if you take a negative number to the fourth power, you end up with a positive result. So there's no need for the plus or minus anymore, because it doesn't matter which case you consider. Raising to the fourth power is going to give you a positive result. So we don't need to write it anymore. So what we're left with is we have the square root of 1 minus cosine of 10x. And it's all under the radical. It's all divided by 2. And we're raising to the fourth power. So what I want to do is, I ignored the plus or minus. I want to think of this as, this is one way to think of it. I want to think of this as all of this is under the square root. And in intermediate or college algebra, you learned that taking the square root is equivalent to taking or raising to the 1/2 power. That's just one way to think about it. So rather than writing this giant radical, I instead raise the radicand, this thing, to the 1/2 power. But then it itself is being raised to the fourth power, mind you. So now this is just a rule of exponents from intermediate algebra, that if you have an exponent of an exponent, the rule is to multiply. So 4 times 1/2 is 2. So what this would come out to be is 1 minus cosine of 10x over 2. And then again, 4 times 1/2 is 2, so we have this as it being squared. So still nowhere near the format that I'm supposed to respond, but moving along, this is indeed equal to this, which is indeed equal to this. By the way, another way you could have thought of the fourth power is, think of the fourth power is squaring something and then squaring again. And again, you'd have 2 times 2 here is 4. So if you didn't like this trick that I pulled where I took the radical and wrote it as the raised to the 1/2, you could have thought of it as, well, raising to the fourth power is the same thing as squaring twice. And the first squaring process would have annihilated the square root, right? The square root and the squaring process cancel each other out. So this square would cancel the square root, but then you'd still have a squaring left, and that's why you have the 2 down here, and the radical would be gone, and you'd have this. So that's just another way of explaining how this fourth power and this radical came out to be this stuff ended up being squared. So to give myself some room to write, I'm almost going to have to erase everything I did and start from this because I'm running out of room. So write this down on a piece of paper, and I will start here in a second. But let me kind of clean the slate, and suppose now you understand how I got that far. I'm going to tackle this by just giving myself some more room to write here. So we got it down where we had 1 minus cosine of 10x, all divided by 2 being squared. So to go another step further, considering that my final answer does not have any squared terms in there, that would lead me to at least believe that I need to multiply this out. So that numerator really is 1 minus cosine 10x, and then what it means to square something is to multiply it by itself. So I'm going to take that and multiply it by itself, which is 1 minus cosine 10x again. And then maybe to save space, just let me deal with the 2 later. Well, I guess I can write it. I'm just going to eat up a lot of my my writing space. So, but remember that the 2 gets squared as well. So I should have actually wrote that as 4 down there. But so my numerator squared, I wrote it as multiplied by itself. Now I'm going to proceed to FOIL. A lot of you can do this in your head, but I'm trying to make the video so that I don't skip any steps. So if you FOILed, you'd get 1 times 1 is 1. This would give you a negative cosine 10x, and it is nice if you can skip a lot of these steps if you could do it in your head, but if not, this is what you'd be doing. You'd have a minus cosine 10x, but this times this would give you another, 1 times negative cosine 10x would produce another minus cosine 10x. And then here, doing the last multiplication of the FOILing, when you take this and multiply by this, you'd have a negative cosine 10x times another negative cosine 10x, and that would give you, having a little trouble with the technology, hold on a second, negative cosine 10x times negative cosine 10x, let me see, a negative times a negative is a positive, and then cosine 10x times cosine 10x can be written as cosine 10x squared, and then the shorthand for that, even though this entire thing's being squared, so what I should do is say this, cosine 10x times cosine 10x is cosine 10x squared, but the shorthand notation to pretty it up a little bit is to put the squared right here, and that alleviates the need for any parentheses. Don't forget that this whole thing was being divided by, right there, 2 was being squared, and I wrote it here, which is 4. I'm still nowhere near this construct here, or at least I'm close. I mean, I've got part of it in terms of cosine here. I still have a cosine squared where I don't have a cosine squared in my answer, and this is the part where I had to dig up some more identities that I didn't have the time at. If you were at today's meeting, we looked at this. I didn't have an identity sheet to remember how that worked, and I don't have my identities memorized, and I should. So before I do that step, though, I noticed that I can combine a couple like terms here. That I have minus 1 cosine 10x here, and I have another minus 1 cosine 10x. So if you've got 1 here and 1 here, that makes 2 of them, but they're negative. So I have the number 1 out here. This and this combine to be minus 2 cosine 10x. And this is simply just still cosine squared 10x. And I have it over my 4. And again, I'm running out of room to write. So I have to kind of clear the slate, or what I can do is I can actually, if I can remember what I have here, open up a new window. So if you have this copied down, what I'm going to do next, let me see if I can squeeze in one more step. What I'm going to do next is break this up into 3 different fractions. All 3 of these terms are being divided by 4. So I could write this as 1/4. See if I have enough room to write here. And then subtract, let me see, this is 2 being divided by 4 is the same thing as a half. So instead of writing 2/4 cosine 10x, I'm going to write 1/2 cosine 10x. So I'm just getting closer and closer to this construct. Right now, if I had to write my answer, this would be a 1/4. And I've got the minus 1/2 there, which I wanted, and I'd put a 10x here, and that would match. I'm still not seeing the fact that I have a cosine squared here and a cosine. And this is where I stopped if you were in today's class and I said I'd go home and make a video, and here's me making that video. But at any rate, right now, this is being divided by 4, so you could think of this as 1/4 cosine squared 10x. Now I'm running out of room to write again, so what I may do is just, if you allow me a couple seconds here, is just so that I don't lose this, copy this and paste it into a new window so that I don't have to rewrite it. So let me see if I can get a copy of this and switch to a new window because I'm running out of room to write, and paste it. And going from here, I noticed, I guess what we also need is what our final answer is supposed to look like. So again, remembering that I need my final answer to be written in this form. And I can tell you, you need to keep that in mind as you do the problem, because what I'm about to do in a few seconds, you would under no circumstance ever think to do that. Like, why would I ever do what Mr. Nearing is doing here? And the reason is because I have this in mind. My goal in mind is to simply get my answer in that form. So I have to find an identity that turns cosine squareds into cosines, and I could only find one. I wasn't sure it was going to work out, so I didn't want to spend a whole lot of time in class doing this. But the identity I need is as follows: that if you have a construct 2 cosine squared of something minus 1, then you can write that as cosine of 2a. So the reason that this identity appealed to me is I have a cosine squared, and I need to write it as a cosine of the first power, and this identity does that. It takes a cosine squared and turns it into a cosine. The problem is it's not quite set up to go. I don't have a 2 cosine squared minus 1. All I have is a cosine squared. So now what I have to do is some manipulation here, if you let me. So I used to remember being as a student, my teacher would do these kind of things, and it made sense that he did them. They were legal, but he never felt the need to tell me why he was doing those things. What would motivate you to do it? So what's motivating me to do what I'm about to do is I need a 2 cosine squared minus 1, and I don't have it. And by the way, you might be looking ahead here and noticing that that I don't have. Well, I guess what I want to do is write this identity in the form I'm going to be able to use it. Since I have a 10x in parentheses here, and this is an a, my identity that I'm going to use is going to be a rewrite of this. So I'm not working on my problem over here. I'm going to be working on the identity. So in my problem, the identity would look like this. So remember, I'm allowed to put anything here for a I want, as long as I do it over there. So looking ahead, one thing I want to show you is our problem doesn't have a single item here, a. R has 10x. So I'm going to use this identity where a is 10x. And that's legal. I can replace a with 10x here as long as I replace a with 10x here. I'm running out of room to write, so hopefully you realize that's 2 times 10x. So replace this side a with 10x, replace that a with 10x, and just want to simplify that down before I go any further. And thank you ahead of time for your attention span. I know this video is getting long, but it's a long problem. So what I have over here to the side is, since I replaced this a with 10x, this a got replaced with 10x, but there's a 2 there. So it really is 2 times 10x, which gives me 20x, which is going to be okay. So what I have is an identity that takes cosine squareds, which I have, and trades them out for a cosine. Now it is a 10x, but that's okay. If you look in here, I'm allowed to write any coefficient here on the x I want. So this is going to be at 20 when I get done. The problem again is I don't have a 2 cosine squared minus 1. All I have is a cosine squared. So what I need to do now is do some trickery here. I've got my cosine squared 10x. So let me in blue copy what I have, and anything I introduce in red will be new to the problem. So what I'm going to do is some trickery, if you will. And I don't mind trickery, it's just that my teachers never gave me an idea why they were doing this. They just wrote it and moved on, and I didn't understand it. So the idea is you need a 2 here to be able to use this identity. This is not going to work without a 2. So the idea is I can put a 2 there, and I'd have that piece of the puzzle. But the idea is you can't go in mathematics and multiply by the number 2. That's illegal. But in mathematics, you are allowed to multiply by the number 1. So what I'm going to do is compensate by dividing by 2. So I really multiply by 2 over 2, which is the number 1. And when you multiply by 1 in mathematics, things don't change. So hopefully that explains why I would throw a 2 in there. I need the 2. The problem is the left side of my identity isn't just 2 cosine squared 10x. I have that now. I have 2 cosine squared 10x. I also need a minus 1, so more trickery in that I need a minus 1 there, so you can put it. And in mathematics, you're not allowed to subtract 1. What you are allowed to do in mathematics is to add 0. Adding 0 to something does not change the value of a number. Just like multiplying by 1 doesn't change the value of a number. So if I subtract 1, I need to compensate by adding 1. And when you first see this as a student, this seems crazy, but you just kind of get used to this idea in math that if you need something, you can put it there, but you got to compensate. So by subtracting 1 and adding 1, I really is just a clever way of adding 0, and in mathematics you can add 0. So because this is color-coded, this is going to come a lot easier in a video than it is anywhere else. The idea is whenever I see this, according to this identity, whenever I see this, I can replace it with that. And I'm about ready to do that. I have 2 cosine squared 10x minus 1 right here, and I'm going to take that and swap it with this. So if you let me do that, it's going to take some time here. And I know this is quite a complicated problem. But the only way to get through complicated problems is to start seeing people do them and to start digesting them on your own. I'm going to do a little bit of a simplification over here. Or maybe not. Maybe I can leave this for now. I've got the 1/4, and I'm going to copy down everything here. And so the idea is I'm going to take this 2 right here and copy it down. I'm going to copy the +1. I wanted to kind of color code this, so the idea is I wish I could kind of copy and paste. Where you see this green square here, 2 cosine squared 10x minus 1, that's this. I need to replace it with this. I'm going to do it in green, so that's cosine 20x. So no magic there. I've got my cosine 20x. And I am glad I did not do this in class because it would have ate up so much time. Anyway, so hopefully you get that. All I did was copy the 2 here, copied the +1. So where you see this thing in the green box, 2 cosine squared 10x minus 1, I replaced it with cosine 20x. I'm almost there. Got rid of all my squaring. This is almost in the form I need it. The problem is I'm only allowed to write cosine something times x, and I have cosine something times x plus 1 out here, and that's not good. So let me do a couple more steps here, and I think I'll be done. And some of you may have your jaws hit the floor by now because there's so many steps to this. But this is how real mathematics is done, and sometimes it's not done in one attempt. Sometimes you pick a route and you do good mathematics, then it turns out to be a wrong step, and you need to start over. And anyway, I'm going to multiply the 4 and the 2 down here to give me 8, trying not to skip any steps at all. So if you let me just do that piece, that combines that. 1/4 times 1/2 is 1/8. So the idea is the 1 gets multiplied by everything up here. That doesn't change anything. The 4 times 2 is 8. Now the idea is that this is being divided by 8 and the +1 is being divided by 8. So if you just let me just write ditto marks here to save time in the video, you could write this as cosine 20x is being divided by 8, and the 1 is being divided by 8. I call this breaking fractions apart. You're probably used to mathematics the opposite of that, where you have a common denominator and you add the fractions. So this isn't me adding the fractions, this is me breaking the fractions apart. So what you're going to have here is the 1/4. We had the minus 1/2 cosine of 10x, and then we have plus, I'm going to think of this as 1/8 here, right? This is 1/8 cosine, and I could skip some steps and make this video probably half the length. The problem is the people that need those steps would never get it. The people that don't need the steps can skip the video, or skip the piece of the video they don't need. So the idea is I have exactly what I want up here. I got a minus 1/2, I got a minus 1/2 cosine 10x, plus 1/8 matches the 20x. I can write 20 here. The problem is I'm only allowed to write a single number out here on the end. So I have to take the 1/8 and the 1/4 and combine that as a single fraction. So I have a 4th, I have an 8th. I need a common denominator to add those fractions. So what I'm going to do is to get the 4 into an 8, I need to multiply it by 2. But what you do to the bottom, you need to do the top. This is another one of the cases where I multiply by 1 in math and not change the value of a number. Right? 2 divided by 2 is 1. 1 times a 4th is still a 4th. Anyway, so I have 2 in my numerator, I have 8 in my denominator. So 1/4 gets written as 2/8. 2/8 and 1/8 is 3/8. So I'm going to, that's supposed to be a 3. I'm going to take and combine those as 3/8, so a fourth and an eighth comes out as 3/8. And then I have the rest of the problem, which I guess I have to write. But probably now you can stop the video and see that I have the answer, and you can fill in the blanks. So the big question really on your mind should be, where in the world would I want to do that? Why in the world would I want to take the original problem, which was sine 5x, all that raised to the fourth power, and write it this way? So that's a video for sort of another class, really. You know, what would motivate us to want to do that? But at least hopefully this video shows, you know, because I wanted my answer in that form, that's what motivated me to pull out this identity that would swap out a cosine squared for a cosine, and then the rest kind of fell in my lap. So to answer the math AS question, this would be 3/8. I already have the minus 1/2 cosine, so this would be 10x. It already has the plus 1/8 cosine, so I would write 20x in there. So hopefully that kind of filled in the gaps, although there were many.